Oh, hi everyone. Uh, as people are coming back after their little 30-minute break, we have another session with Mark Rader. This time we're getting a 2-for-1, and he's brought along Tori Felt, also from the Washington Service Center. So hi Tori, hi Mark, welcome back. Um,
Thank you, Marcus.
we'll give it another minute because people generally turn up a little bit late the first thing after the afternoon. And then I'll hand over to you. So this is session 9I for everybody who's joining. Please don't forget to put your comments and feedback in afterwards. And any questions that you may have, please type them into the chat and we'll read them out or leave them to the end, whichever one you want. Other than that, it gives me pleasure to hand over to Mark and Tori. Over to you.
All right. Thank you very much, Marcus. Welcome, everyone. And I'm very pleased that Tori was able to join me today. She and I have been working on health checks for a number of customers in the Americas. And we just wanted to share some of the things that we see and some of the things we encounter to give you things to think about for the health of your DB2. The agenda we're going to follow today. First of all, I'll talk briefly about what I mean when I say a DB2 for zOS health check, or I'm sorry, DB2 for zOS health check, which focuses primarily on high availability. We'll talk about the topics that we cover, and Tori's going to talk about the data we look at and the kinds of tools that we use. And then we're going to step through some of the topics that we look at, not only talk about some recommendations, but also just describe the sorts of things that we think about and look at when we work with customers. So obviously for availability, we care about parallel sysplex and data sharing, but we have a number of non-data sharing topics that are important to look at, as well as a few DB213 specific items. I am not able to see the chat for questions, so I'll ask Marcus or Colin to interrupt me if there is a question that's pertinent to where we are right at the moment. And we should have time to answer questions at the end as well. So the health check process that we follow actually includes lots of other subsystems. Just Tori and I work on the DB2 one. So we collect a bunch of data. We typically go on site, it could be virtual, to have interviews with customers about how they do things, how their systems work, how their applications flow. We pull together a draft report to review it with the customer to make sure they understand the recommendations we make, and that we didn't get anything factually wrong about their environment. And then we finish up anything that needs to be finished up and send them final report. And this takes weeks, actually, to do all of this. The focus of our health checks is about availability, right? We look at high availability, we look at continuous operations and put the two together for continuous availability. And we also touch on disaster recovery or business continuity, depending on how you define that. It seems obvious that we would talk about the technology things, and in our particular case, we'd be talking about DB2 for zOS. But when we do this, we also talk to our clients about automation and what they're doing in that space. And it's important for us to understand their applications, right? How is their business using the environment, especially DB2? Are they taking advantage of the opportunities that DB2 gives them for availability? And then we, of course, talk about maintenance testing and disaster recovery. We spend a little less time on the people and process than some other parts of IBM, like the High Availability Center of Competency, but we do touch on those. So we're primarily about availability. What about performance? Well, the problem is that really bad performance can appear to the end user to be a lack of availability, right? If the website I go to and click on doesn't respond to me in a fairly short period of time, I give up on it, even if it might be a performance issue behind the scenes. So we do look at performance. It's just not our primary focus. But anything that is really significant, we're going to talk to our clients about. Tori, I'm going to turn it over to you.
All right, thanks, Mark. For the data and tooling, so when we do these health checks, we ask the customer to send us a bunch of their data so that we can look at their environment and see if there's any room for improvements. So we ask for example, like SMF data, display data, and we'll use various tooling to kind of aid in our analysis. So for example, we use ZCP 3000 when we're looking at different like coupling facility data or looking at different trends. They have a lot of uh, detailed charts that just come with ZCP 3000. And then, for example, Excel, Microsoft Excel will make pivot charts and look at uh, SMF and display data to see what's going on. We use the RMF spreadsheet reporter. Python, we use actually for, we have a program that looks at the list cat and generates a result looking at the list cat to see if they're meeting the requirements or not. And of course, we use ISPF and TSO. So a whole bunch of analysis is going on behind the scenes once we get all of their data, and definitely use various tooling with that. Now, the next slides that we're going to walk through here are going to be some of the topics that we focus on when we are doing these health checks. So it's kind of a standard list of topics that we go through and we always look at with each customer. And there's definitely frequent findings. Like, for example, we see that a lot of customers have certain thresholds set for their group buffer pools, something like that. So there's frequent findings, there's recommendations depending on what we see in the environment. And I saw a question come through the chat. Marcus asked, what's ZCP 3000? So ZCP 3000 is an IBM tool that is used to look at SMF data. You can upload a customer's data directly into the tool, and there's a bunch of like charts that are built behind the scenes, and you're able to like look at different coupling facilities, structures. Mark, you might have more information on ZCP 3000.
Right. So I think the primary use of ZCP 3000 is when the IBM team is helping a customer do capacity planning for their, to shift their new environment. So, for example, a lot of customers are now looking at Z17s, and the question is which model of the Z17 is going to meet their requirements. And ZCP 3000 can take their existing SMF data and make, and they can use it to model the various Z17 models to see which one is going to be the most appropriate for their workload combination, right? There are so many variations, it makes sense for the IBM team to go through and narrow it down to one or two appropriate ones, and then work with the customer to see which of those are going to fit their planning horizon better.
Great, thank you. Okay, Db2 and parallel sysplex. So when we meet with the customers, we definitely look at their data, but we also have like interviews with the customer where we ask them questions about their environment that Mark kind of mentioned. So we'll definitely ask about their configuration, and we'll look at their data sharing group configuration. The diagram to the right, that is just a general data sharing configuration, very basic, not a lot going on, but that is what you can consider a data sharing environment with your SCA, lock one, group buffer pools, 2 members, and we definitely encounter multiple configurations. So everyone's environment is a little bit different. We have looked at customers that have like multiple data sharing groups with many members in each group, or we've looked at, like a 2-way data sharing, 1-way data sharing. There's a lot of options and a lot of configurations. One of the main recommendation And something we look for is to make sure that the DB2 same system and cross-system restart are automated. Sometimes customers have maybe one of them, like same system automated, but not cross-system. But it's very important for availability to have these automated. So that's one of the main topics that we investigate. Coupling facility structures. So this is some of the recommended best practices that we look for and we recommend to customers. Specifically for group buffer pools, you want to specify the init size. The duplex should be set to enabled and allow auto yes. So this is all best practices. Again, we have seen customers have these settings. We've seen them not have these settings. It's depending on the environment, but we are always going to recommend these specific settings. You can see on the right, that is an example of a CFRM policy. So you have group buffer pools. You can see the size is set, the init size, you have allow auto yes and duplex enabled. And the lock one and SCA is also listed here. For the lock one and the SCA, you also want allow auto to be yes, that is appropriate. But definitely for group buffer pools, duplex enabled is strongly recommended. If we do not see this enabled, we will definitely tell the customer to set that if they can to enabled. And then failure isolation of the lock one and SCA is very important as well. So if you're failure isolating the lock one and the SCA from your members of the data sharing group, that could be done in really two ways. So this first picture here, we're duplexing the lock one and the SCA structures. So the lock one is either synchronous or asynchronous duplexing, and then the SCA is synchronous duplexing, as we see on KEC 3 there. So that's one way to make sure that you are failure isolating your lock one and SCA. There's also another option, and that would be allocating the lock one and the SCA on a coupling facility that is not on the same KEC as the DB2 members of that specific data sharing group. So the lock one and the SCA in this example is on a different KEC from the members of the data sharing group that's on KEC 4. So really, again, the main idea is making sure that the lock one and the SCA are failure isolated from the members of the group. We do see some customers that do not have this failure isolated, and that is definitely a big recommendation that we talk about right away. Make sure that they understand the need to failure isolate the lock one and the SCA. Monitoring the lock one and SCA. We recommend to customers to monitor both the lock one and the SCA. For the lock one specifically, we're looking at synchronous requests, synchronous service time, subchannel busy, and real and false contention. So when we do our analysis, we look at the RMF coupling facility activity report, and you can see all this information in there. And we basically look for like anything that is out of the ordinary or really high numbers or something like that. But we also tell the customer to monitor both of these as appropriate. For the SCA, it's important to monitor the percentage of the SCA in use. So this is available actually in the display group, also in structure full messages. Group buffer pools, so when we get display and SMF data, we can see all of this for our customers, but we're mainly looking to make sure that these three values are all 0. So the write failures due to lack of storage, directory entry reclaims, and then cross invalidations due to directory reclaims. In my experience, oftentimes customers do like we do see these numbers at 0, but there are times when they are not 0, and we will go into their group buffer pools and do some analysis and kind of see what's going on, and then make that recommendation to possibly tune something to make sure that those numbers drop.
So one thing, Tori, that I forgot to mention here on the slide was that these messages are part of the output of display group buffer pool G detail.
Oh, yes.
So if anyone watching is like, well, where do I find this? This would be in a display group buffer pool G detail option, which tells you this for each of the group buffer pools. You'll get this set of messages that you can then look at. When we look at it, we usually run those through a Rex exec, so it puts it into a spreadsheet, but sometimes we still look at it in this format.
Great, thank you. All right, more on monitoring group buffer pools. So this chart was taken from Excel. So we used SMF data, put it into a CSV file, and created pivot charts to look more closely at data. So in this example, we have cross and validate data return ratio, and then the XI reads per second. So the blue is the percentage of XI reads with data returned from a group buffer pool, and then the orange is XI reads per second to the group buffer pool. And this is showing an example of good read hit ratios. So really the idea is that you want high XI read hit ratios, really for all group buffer pools, but definitely for the ones with the highest rate of XI reads. So sometimes when we're looking at data, we see some numbers that have some really low ratios with high XI reads. So that's important to take note of. And yeah, this is what you want to make sure that your group buffer pools, high ratios have high rate, or the highest rate of XI reads have high ratios. The recovery log. So again, when we do these health checks, we are recommending best practices. And some of this data we get from asking the customer directly, but also looking at their data. So for example, like we'll ask the customer, do you have, like, are you aware of, do you know if you're covering 6 hours, 24 hours? And sometimes they may say yes, and then we look at their data and that's not the case. So it's important that we kind of take it from both points of view. But the best practice for the recovery log is to deploy dual logging and dual archiving. So definitely have at least 6 hours of the active log coverage, and then make sure you ensure at least 24 hours of log on disk, and that is considering both the active and archive log data sets. And then best practice is to failure isolate the log copy 1 and log copy 2 data sets, as well as your bootstraps as well. And this could look like separate disks, or even if you're using Hyperswap, that would be failure isolating your log copy 1 and log copy 2 data sets. So again, customers have different settings and different ways of doing this, but either separate disks or Hyperswap are 2 examples. And then we discuss the recovery process with the customer. So we'll ask them, like, how often do you test recovery? What is that testing? What does that look like? What is your process for doing that? And we want to make sure that their catalog and directory, as well as the user data, that they're both protected by the image copy strategy. And we've seen sometimes customers are using image copy, some are not. Some are using incremental image copy, some are not. So there's different variations, but we want to make sure that they understand the importance behind that. And then their recovery, we just want to make sure they're, testing their recovery and documenting the process so that the whole team is kind of an understanding as well. Maintenance. The best practice for maintenance is to apply the RSU maintenance. We say typically 2 to 4 times per year. and to coordinate the RSU levels with the operating system and other subsystems. And then we recommend to receive hypers and PE fixes frequently to make sure that everything is good. Sometimes, most customers have this, but it just depends. So we will definitely recommend this in our report.
We have unfortunately encountered recently a couple customers who are years behind in maintenance, and that causes lots of problems. If they do suddenly have to apply maintenance, they may have many prereqs to apply, and it slows down the process. So yeah, staying current is a big deal.
Yes. For migration, we ask and make sure that customers understand, the continuous delivery process. So we make sure that they're reviewing new functions and capabilities. So when I say introduce to DB212, sometimes we have customer that is maybe getting ready to migrate to DB213. And then we ask them about their process for reviewing new functions, capabilities, and sometimes they don't even take advantage of the DB212 enhancements and capabilities that are available because maybe they're not aware of it. So, we recommend to look over the capabilities in DB212 and then definitely for DB213 and to migrate to DB213 as well before it's end of support for DB212. But yeah, sometimes again, customers have been on 12 and have never looked at or taken advantage of the features. So it's just a little reminder. When migrating to DB213, it's important to rebind all of your packages, and specifically high use packages, you want to prioritize those. But we just recommend just to consider rebinding all of your packages when migrating to DB213. If you're concerned with access path changes, you can use the AP reuse and the AP compare to manage your access paths. And pay attention to the bypass calls that you can find in the SMF 100 records. So there recently has been a case where there was a really high number for bypass calls, and it was just a quick little tweak that the customer had to do. And this was found looking at the IFKID 224 records with package details related to that. So that's bypass calls is often something that maybe people skip over or don't pay attention to, but we look at in our analysis for these health checks. And then this last point here, ensure source control always specifies the appropriate application compatibility for bind operations. And also this star here, plan management extended, is a prerequisite for rebind phase-in. So sometimes we see customers that have plan management set to basic, for example. And we definitely will take note of that and recommend setting that to extended because that sets the default. And it's important that customers are aware of that. So we did have a question. What does bypass calls show and what causes it? So to my knowledge, when DB2 is it must bypass fast column processing if a package has not been bound in the current release. So then those bypass calls will show up in the SMF 100 records and basically will show how often DB2 had to bypass that fast column processing. But Mark, you probably have more information on that as well.
You've hit it. If you run, for example, a version 12 package in DB213, a DB213 can run the version 12 package, but it won't be as efficient as a DB213 package. And simply rebinding the package, even if you use AP reuse and keep the same access path you're familiar with, it will be a more efficient package and the performance will be better. A version 12 package running in version 13 cannot take advantage of fast column processing, like Tori said, and typically that's going to be the select proc. Now, for some customers, this is significant, and others it isn't. but I've been in a number of shops where once we looked at their number and showed them, they were able to identify the CPU performance that they were paying for having old packages, and a quick rebind brought them, and reduced their CPU cost. So it's in the most recent situation, our other teammate Kazai and I were with a customer who had a huge number of bypass calls, which is, if you're looking at statistics long report, it's in the miscellaneous section. If you're looking at the online screens, I'm not sure where it is. They had a huge number, and when they ran the report on IFKID 224, it turned out that there were only a handful of packages, and one of them was responsible for well over 95% of the bypass column processing. And so by rebinding that package, they were able to reduce that number to a fraction of what it was and save a lot of CPU.
Okay, buffer pools. So buffer pools are definitely complex, and they look different in customers' environments. So this is a very high level overview of what we look at during the health check analysis. We're really looking for obvious problems that could inhibit customers' environments. So that could include thresholds. We're looking at their thresholds, for example, VP, SEQT, to see, do they have the appropriate settings? We're looking at their buffer pools to see, are there a very high number of synchronous reads or a very high number of synchronous sequential reads? Are they taking advantage of page fix? Yes. Or are they, not using that? Or do they have large frames, but they're using page fix? No. So for example, there's a lot of different ways that customers have their buffer pool settings. So we just want to make sure that they're, that their environments are set to the appropriate settings. And Mark and I were saying, buffer pools this could be a good idea for a future session on what we look for in buffer pools, because it's very complex.
And all right, thanks, Tori. Maybe we'll submit that for fall GSE UK meeting.
And Mark, before you get started, we have one question come up. Any plans to implement some of the DB2 best practices as IBM Health Checker checks registered by the DB2 subsystem upon startup?
So I think what that question means is, if someone's running the IBM zOS Health Checker, would the things we're talking about here in DB2 go into that health checker? And that's a fine question. I don't know the answer. I have not had a conversation with anyone at the lab about including these things in the health checker. We do have a fascinating and powerful tool called Db2 zAI, or Db2 AI for zOS. And that tool has three components, one about optimization and runtime enhancements, the other about system assessment, and the third about distributed connection control. And the system assessment would include many of these things that we're talking about. And a customer can then do their own health check using this Db2 zAI tool. But I don't know of plans to put the things that we look at into the zOS health checker. Thank you for the question. Next topic we look at encryption. Security and cybersecurity is an important point for many customers. And when we look at encryption, there are actually three things that we ask about. One is what I'm calling media encryption. And this is the lowest level of this encryption pyramid here. And that's where the actual the storage or tape controller is going to encrypt the data as it goes down onto the disk or the solid state. So that's the lowest level of the pyramid. And I say everybody does this. That's not quite true, but the vast majority of shops are doing that. And I consider this, we can call it data in flight because it's moving from the controller down to the media, but primarily this is about data after it's gotten to its target. Then there's the phrase that IBM uses called data set encryption. And that's about encrypting data between the Z system and the storage controller. So for example, if there's a sysplex that's stretched across a geographical area, a lot of the traffic is going over fiber that is not controlled by the customer. And so you probably want that data to be encrypted as it travels there. So when I pop in this blue oval, that's what we're talking about here, data set encryption. Db2 has been supporting that in various, passive and active ways since we announced this back in 2017. And fundamentally, the idea is that DFSMS does the work to encrypt and decrypt the data. And then the key labels that are used to define which encryption keys are used can be set either with RACF or various explicit approaches, including DB2 or with the SMS data class. And the vast majority of customers that are doing this are using the RACF dataset profile because it's a separation of duties and they have a security team do it. The third level of encryption would be column-based encryption. And so that's things that are supplied by the database. And in the case of DB2, it would be the built-in functions that were added in version 12 of function 504. And that would be the encrypt data key and decrypt data key, where the application is aware of the encryption, but they're using DB2 built-in functions to do this. And then the top level of the pyramid for super secure and important things is where the application itself is doing the encryption, right? So the application exercises encryption algorithms. And so some shops do that, and of course that's not something that DB2 will do for them. But one thing to note is that with column-based encryption, the data is going to be encrypted in the buffer pool, right? And that would be true of application encryption as well. We look at memory. Again, this is a topic we could spend lots of time on. We look at virtual storage. We look at real storage or real memory, depending how you define that. Among the things we look at are things like eCSA consumption, which is less of an issue for most customers now than it used to be in, say, version 8 or version 9 timeframes, but we still look. And then we also look at real memory, the example chart here on the right about the real storage available to the various subsystems we were looking at. And you may say, oh, well, those yellow and gray lines are really low. Do they have enough real memory? Well, the picture here is so tiny, but that's actually 50 gigabytes of real available even to the yellow and gray subsystems, which is plenty, right? We're looking to make sure that there's more real memory available than the max space defined. In other words, you'd be able to take a dump successfully. IFCID 225 is the primary input. This is part of statistics class 1. And there is a MEMU2 RexExec. And if you go to the DB2 community link listed here, you can find out about and download that and use it to evaluate your environment, your virtual and real storage usage in your environment. Another thing we look at is distributed access. And so that would be the things that are coming in and out of DB2 through the DIST address space. One of our first questions is, what is the role of DDF in the environment? And what we find is that for most shops, DDF is the fastest growing volume of work, right? They still get a lot of work and organic growth in, say, CICS or IMS or MQ, but the DDF is where they're getting most of their growth. And the things that we look at and think about and talk to our clients about would be, are they using secure ports, right? How are they meeting their security and encryption requirements? We look at whether they're using locations or location aliases, and are they taking advantage of the flexibility that provides them? How are they managing connections and threads, right? How close are they getting to the limit of connections, ConDBAT, or the limit of threads, MaxDBAT? And are they using system profile monitoring? Yesterday, our teammate Keziah presented on system profile monitoring. It was session 9C. In case you missed that, I would recommend you take a look at that. We look at the idle thread timeout. Some customers have that set appropriately. Others are doing very interesting things to their applications by setting those on behalf of one application and then causing the others to deal with it. And again, profile monitoring is a way to address that. We talk to customers about how they define their data server drivers and how they keep them current. We look at the queue time, right? How long are new connection requests waiting to get a DBAT? And then we talk to customers about whether they've deployed high performance DBATs, right? High performance DBATs is a way to reduce the CPU consumption around distributed threads that are likely to always be present in the system. But there are some, they get managed differently, and so there are things we need to talk about. One of the key things we talk to people about is Sysplex Distributor. Now, I know this is a complicated picture on the left, and I didn't move it over enough to be able to read the word request sufficiently. But Sysplex Distributor is how an initial DDF request would find which DB2 member of the group to handle that connection, right? And Sysplex Distributor has a variety of distribution methods. So we look at not only how is it set up, but which distribution methods are being used. We prefer server WLM because that takes into consideration WLM information about the DB2 members. Related to this, we also want to make sure that customers are using a distributed dynamic virtual IP address, or a DD-VIPA, for the data sharing group. So a specific DD-VIPA for the data sharing group that isn't used, by others or LPARs or whatever, and that each member of the data sharing group has its own member-specific dynamic virtual IP address. And then our preference is that the DD-VIPA and D-VIPAs are defined in the bootstrap. And the DD-VIPA is called in the bootstrap the group VIPA. And so that gives DB2 the most flexibility and the most high availability in case of a recovery restart situation. Then there's Sysplex workload balancing. And we frequently find that customers who are not DB2 experts, and even some who are, stop listening after the word Sysplex. And so they confuse Sysplex Distributor with Sysplex workload balancing. So Sysplex workload balancing is a different thing, right? In this case, it is the green checked rectangle right down here that's describing how Sysplex workload balancing happens. The point is that at a transaction boundary, the driver can choose to use a different transport and go to a different member of the data sharing group after a commit or a clean rollback. And the choice as to which member to go to will be based on the weighted server list that DB2 returns to the driver every so often. That includes information like the WLM performance index, or whether or not this DB2 is approaching ConDBAT, or if there are other constraints in a DB2 or an LPAR. So this diagram at the right is a relatively simplified one to give you an idea where Sysplex workload balancing fits in. So we definitely talk to customers about taking advantage of that. Again, we have a separate section to talk about system profile monitoring, which originally was just for DDF traffic, but starting in version 13, it also applies to local threads, especially current lock timeout special register and deadlock resolution priority global variable, and the new package release setting. Again, these were probably covered in Keziah's presentation yesterday, session 9C. But we could sometimes spend a lot of time talking to customers about this and setting up a separate 1 or 2 hour session to review the capabilities that they're not taking advantage of. ZPARMs. We do look at ZPARMs. We go through the long list of ZPARMs, and we don't look at every single one of them, but we look at a lot of them. Specifically, we're looking at availability related ZPARMs, but also some performance, usability, resilience, and security settings. There are so many. This probably deserves at least one full session at GSUK. Maybe we'll propose that. But a few notable ones that we've looked at recently include the the zparm that sets the maximum for your current lock timeout special register in DB213. The default, because there is no prior behavior to protect, the default is to have no limit on what someone can set their special register to. That's an awful default. So every time we work with a customer who's either about to go to version 13 or is in version 13, we talk to them about this the setting in zparms to make sure that they don't take the default and put an appropriate value in there. Another one that we pay attention to recently is index memory control. This is about using index fast traversal or FTBs, which we recommended back in 2016 when version 12 first came out that customers not use until we cleaned up technical debt. Customers should be using them now. And so we definitely look at that. And then one of the interesting ones, a lot of customers have some very interesting values for the number of locks per table space and number of locks per user. And what's important to note is that in version 12, DB2 provided global variables that you can set at an application level to have a specific value for that application that corresponds to the number of locks per table space or number of locks per user. So you can have a reasonable number in zparms for the whole DB2 environment, and then for specific exceptions, you can set those global variables. And like I said, there are so many zparms, we can't spend too much time on them right now. And finally, we look at compression. Most of the customers we work with do use table space compression. So this is where you set compress yes for the table space. We ask a lot. Relatively few have deployed Huffman compression, which was introduced in version 12, function 504, and enhanced in 508. Most customers do use the DSN1 comp standalone tool to evaluate compression because it gives you an idea of how much disk savings you'll have and potential costs relative to compression. But because the compression algorithms favor read, you can actually improve performance because the data stays compressed in the buffer pool for table space compression. Some customers are using zEDC compression for DB2 resources, in this case labs. A lot of customers are using zEDC or zEDC for non-DB2 resources. And then very few of the shops that we work with are compressing indexes. Right? Index compression is software compression. It doesn't take advantage of on-chip compression efficiencies that table space compression does. And it requires that the index buffer pools be larger than 4K. And primarily, this is about disk savings. It's not about performance because the indexes are decompressed in the buffer pools. So those are the things that we look at. So before I summarize, did any other questions arise, Marcus or Colin?
Yeah, there's one question, Mark, about running ifkid 224, whether that's costly or not.
So running ifkid 224 is not very expensive. I don't have a number. When Kazai and I were at a customer who had that large number that I talked about earlier today, they asked that question, how expensive is it? So I checked with the lab and they said, no, it's relatively small cost. Because DB2 is keeping a counter every time it has to bypass column processing anyway. And all you're really doing if you run ifkid 224 is you're gathering the information about the package name. So if you look at DSN-W MSGS for ifkid 224, it'll describe the fields you're getting. And then if you run ifkid 224, you can then go parse that. And like I said, in this particular case, one package was responsible for the vast majority of it, and a simple bind was able to solve it. So no, very low cost. Okay.
That was our last question.
Okay, super. So just to summarize, our DB2 for zOS health checks focus on high availability. But because of the nature of the environment, and its complexities, we do look at some performance, security, usability, and operations aspects, right? Because all of these play into how healthy a DB2 environment is. We look at data sharing and non-data sharing topics. Even customers who aren't doing data sharing can improve their availability with appropriate practices. Things like speedy recovery and testing recovery, and making sure recovery procedures are documented in a way that a non-DB2 person could perform them in an emergency. As Tori described, we look at SMF data, we look at display output, we look at job output like DSN JU004 to understand the log environment. And so we take all this output, and then we have a variety of tools that we use to help us analyze and to direct our questions when we meet with the customers. There are many common themes that we tried to touch on, but we also encounter many variations because each organization has its own requirements and its own objectives. And so a value that may be useful for 90% of customers may not apply to them. And so part of what's interesting about doing these health checks is that we do get these variations, and we get to learn not only how different organizations are approaching their goals and objectives, but also different ways to use DB2 capabilities to match them. So thank you very much for your time. If you think of additional questions in the future, please reach out to us. And hopefully we'll get to see you in Whittleberry Park. Please do not forget to submit your session feedback. I don't know if the JSC UK is sponsoring charities in the virtual event as well, but please do that as well. And thank you very much for your time.
Thanks, Mark. Thanks, Tori. Don't forget to leave your feedback for session 9I, and I wish you all a great afternoon. We shall see you in half an hour for Anthony Chabertoni's talk on best practices for managing distributed applications.
Thanks very much,
Everyone.
Marcus and Colin. Thank you, everybody.